Now if you go ahead and open up the tool again, and we'll try the decimal to binary conversion. So click on this, and you'll see you get the conversion tool here. Now it's a bit bigger because I've got a bit more information to show on this. Now let's say for example we wanted to convert the number 17.125. So we've got 17, so if I put the 17 in, well, it's done the conversion for 17 right away. Here's the value for 17 up here. Now you can ignore the little bits in red. We're going to be using those in future videos to work out the rounding, so just ignore those for the moment. The 32 bits are from here all the way along. We've got our 23 bits in green for our mantissa, our 8 bits for our exponent, and the yellow bit at the end there is for our sign. So you can see here that I've actually went through the little algorithm in order to work out the binary for 17. Now generally you wouldn't need to do that because it's easy enough to work it out. You're going to have 1 plus 2, 4, 8, 16. So you have 1 plus 16 is 17. And generally you're able to work those out relatively quickly in your head, because if you're doing pen and paper stuff you're going to have just small numbers. But here's the algorithm anyway. We're going to have 17 divided by 2 is going to give us a value of 8, and we'll have a remainder 1, and that's this one here. We're going to have 8 divided by 2 is 4 and remainder 0. 8 divided by 4 divided by 2 is 2 with a remainder 0, which is this one. We're going to have 2 divided by 2, which is a value of 1, and the remainder is 0, which is this 0. And we're going to have 1 divided by 2, well 2 doesn't get into 1, we'll just have a remainder 1. So the number here then is going to be read as 10001, and it's maybe better if I put a different number in here for the moment. If I put the number 9 in, you'll see that we're going to have, or 12 is a better number, put 12 in, you can see that we generate the number here and then we read it from the bottom up. So from the bottom up we go 1100, so that's 1100. Okay, so I'll go back to 17 here because I'm going to extend in this number. So the value is 17. Now there is no decimal point, so you can see that these are all 0. So I have to finish off building this little tool, but I should finish it off within the next few days, in which case you'll have the updated version available to you, and of course I will have redone this video as well. So we'll have all zeros in here, and you can see that the decimal point is at this point here. So the decimal point, in order to normalise the fixed point number that we'll have here, we're going to have to move this decimal point up till we get to the a reading 1. So we're going to have to move it 1, 2, 3, 4 places. Now whenever we've moved it 4 places, we'll have our value for our unbiased exponent, which will be 4. And then we're going to have to add the 127 on to get the biased exponent, and we'll get our final exponent value, which is a value of 131, and that's the 131 here. So that's us done the exponent. Of course we can do the sign as well. The sign's straightforward enough. It's just going to be a 0 is going to be a positive value, and a 1 would be the negative value. So if I had to put a negative here, you'll see that going to 1, and if I change it back to the positive, you'll see it going to the 0 again. So there isn't any fractional part here, but if I was to add a fractional part, so let's say I put in 0.1125. Now you can see here that in the fractional part we work through the little algorithm. 0.15 times 2 is 0.25, and that's less than 1, so we get a remainder 0. 0.25 times 2 is 0.5, and again that's less than 1, so we get 0. And we head back down to here, we've got 0.5 times 2, which is 1. Now you can see here there's a little blip in my code, because this 1 here should actually be here, and then these should be all 0, so there's a little blip in my code which I'm going to have to fix, but I'll fix that in the next few days. I just thought I'd get the video together just to show you, and it's still of use and still of value to you to see how it works. So what we would really have here then reading down, if this was working properly, it would be 001 and then all zeros, and you can see it's actually written okay here, so we've got our 001 and all zeros. So this here is our fixed point number. So in order, as we said, to get that value of 4, what we would have done, we would have taken the decimal point and we would have moved it up to 1, 2, 3, the 4th position. So the decimal point would now sit at this position here. So that means that the mantissa is going to be from this point here, counting 23 digits back. So the mantissa is going to be 0, 0, 0, 1, and then 0, 0, 1. So you see 0, 0, 0, 1, 0, 0, 1, and all zeros. So that's how we generate our mantissa. And you can see that this one disappears because this one here is the hidden bit. And whenever we do the conversion back to the floating point, we don't have 24 bits here for mantissa, we only have 23, so we just drop this bit. We don't need it, it's already understood. So that's a simple conversion process. So it means that you can put a few numbers in and you can work through this conversion in Excel VBA. So that's all there is for this video. In the next video we'll put these two together and we'll see how we do the conversions together and we'll be able to make a comparison. So thank you for listening, I'll get you in the next video, goodbye.